Hello guys, today I am going to teach you the chapter Is Matter Around Us Pure? The name of the chapter itself is a question. Is matter around us pure? So to answer this question, we need to know two things. What is matter and what is meant by a pure substance? So let's look into that. What is meant by pure substance? For a common man, pure simply means having no adulteration or contamination. The word pure is often used in advertisements. The milk is 100% pure. The beauty product is 100% pure. They simply mean that it is without adulteration or contamination. But for us scientists, for us students of science, a pure substance means one which only consists of a single type of particle. Let's look at this diagram. Consider this is a substance. For it to be called pure, you should be able to take any two particles randomly and they should be identical. That is what is meant by pure substance. Next, we have to learn what is matter. Matter is anything that has mass and occupies a volume. Everything in the universe is made up of matter. Everything you see around you is made up of matter. Now, matter is classified into pure substances and mixtures. Pure substances are further classified into elements and compounds. Elements are those that cannot be broken down into simpler substances. For example, copper, oxygen, iron, hydrogen, mercury, etc. Compounds also have fixed composition, but the difference is that they can be broken down into elements by chemical or electrochemical reactions. Examples are water, methane, sugar, etc. The next type of matter is mixture. So, what comes into your mind when you hear the word mixture? What comes into my mind is the stuff we call as mixture. What we have at our homes and we eat a lot. When we think about it, mixture is actually mixing a lot of stuff together. That is exactly what a mixture is. A mixture consists of more than one substance mixed in any proportion. Mixtures can be separated into pure substances using appropriate separation techniques. There are different techniques for different types of mixtures, and mixtures are classified into two: homogeneous mixtures and heterogeneous mixtures. The word homo means same, and the word hetero means different. Homogeneous means it has a uniform composition, same composition throughout. Whereas heterogeneous, it has a non-uniform composition, it has a different composition. Look at this diagram. We can see that they have a pattern. Whereas when you look here, it is not uniform. It's obvious from the figure, it's not uniform. Next, another point of difference is that homogeneous mixtures cannot be separated out physically, whereas heterogeneous mixtures can be separated out physically. Just think about two examples of each. An example of each. An example of a homogeneous mixture is salt dissolved in water, and an example of a heterogeneous mixture is water in oil. So the salt dissolved in water cannot be separated out physically, but you can easily separate water in oil. They form different layers, so they can easily be separated out by physical process. Next, we are going to look at different types of mixtures. First type is solution. A solution is a homogeneous mixture of two or more substances. Simple example of a solution is NaCl in water. So there are two components of a solution. They are solute and solvent. In the above example, NaCl in water, the NaCl is a solute and water is a solvent. The solvent is that component that dissolves the solute particles in it, whereas solute is the one that gets dissolved in the solvent. The solvent is usually present in larger amount and the solute in lesser amount. As we observe in our surroundings, solvents are usually seen in liquid state. Usually dissolve stuff in liquids, right? So the solvents are most commonly seen in liquid state, but they can be in solid and gas as well. Whereas solutes can be solid, liquid or gas. So the example of a solvent-solute combination is NaCl in water. NaCl is a solute and water is a solvent. Next, properties of a solution. A solution is a homogeneous mixture, which means it has uniform composition throughout. The particles of a solution are smaller than 1 nanometer in diameter, means 10 raised to minus 9 meter. It's that small, which means obviously they cannot be seen by the naked eye. And because of this very small particle size, they cannot scatter a beam of light passing through the solution. So when you put a torch through a solution, the path of light will not be visible. And the solute particles cannot be separated by simple physical process as we have seen, like filtration. Next, we'll look into concentration of a solution. Depending upon the amount of solute present in a solution, the solution can be dilute, concentrated or saturated. So dilute and concentrated, these are actually comparative terms. The meaning is that, consider you take 2 glasses of water. They have the same amount of water in them, and in one you add 10 grams of NaCl, and in other you add 20 grams. So here NaCl is a solute and water is a solvent. So we are making 2 solutions in which in one solution we have added 10 gram NaCl and in the other we have added 20 gram NaCl in the same volume of water. So comparatively we say that the one in which we added 10 gram NaCl is dilute and the one in which we added 20 gram NaCl is concentrated. Dilute meaning that it has less amount of solute, concentrated meaning that it has more amount of solute. Next, what is meant by saturated solution? So let us look into what a saturated solution is. Consider that you take another glass of water and you start adding salt. And you keep on adding salt. And when you do this, you will reach a point where if we add more salt to it, it won't dissolve. That means it has reached its maximum capacity to dissolve salt. And this is happening at room temperature. Make sure to note this point. It is happening at a particular temperature. So the point at which if you add more salt to it, it won't dissolve. That point is called the saturation point. So a saturated solution means at a particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. Note the point at a particular temperature. So the amount of solute present in the saturated solution at this temperature is called its solubility. So the amount of salt you add to the water to make it saturated is called solubility. And solubility actually depends upon the temperature. Consider that you added salt to the glass of water and made it saturated at room temperature. Then you started boiling it. You started boiling that solution, and then if you add more salt to it, you'll see that you can dissolve more salt in it. That means its saturation point has actually changed and its solubility has actually changed. That is, the amount of salt that can be added, that it is capable of dissolving, has actually changed. And if the amount of solute contained in a solution is less than the saturation level, it is called unsaturated. Saturated and unsaturated. Saturated means it has reached its maximum capacity, and unsaturated means it has not. Next, different substances in a given solvent have different solubilities at the same temperature. Let's take an example again. 2 glasses of water, same amount of water in each, and into one you add sugar, and in the next you add salt. So the aim is to make both of these saturated solutions. So the thing is that the amount of sugar required to make this solution saturated, and the amount of salt required to make this solution saturated is actually different. So the point is that the solubility actually depends upon the solute as well. The concentration of a solution is the amount of solute present in it in a given amount of solution. The amount of solute present in a given amount of solution or in a given amount of solvent. But we usually take amount of solute present in a given amount of solution. So we can look at mathematical expressions of this. The first one is mass by mass percentage of a solution. So I have already said it's a given amount of solute present in given amount of solution. So mass by mass means mass of solute by mass of solution into 100, as it's mass by mass percentage of a solution. And mass by volume percentage of solution means mass of solute by volume of solution into 100. The 100 because it's a percentage. Next, suspension. What is a suspension? A suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended throughout the bulk of the medium. An example is, again take a glass of water and then add chalk powder to it and try dissolving it, try mixing it well, and then leave it undisturbed for some time. That's an example. You will see that it actually settles down. That means it never gets uniformly distributed throughout the solvent. That means it is not a solution, it's not homogeneous. The properties of suspension. Suspension is a heterogeneous mixture, means it does not have uniform composition throughout. The particles of a suspension can be seen by naked eye. You can see the particles of chalk in the water. The particles of a suspension can scatter a beam of light passing through it and make its path visible. The solute particles, when left undisturbed, they settle down and can be separated by simple process like filtration. The fact that they settle down when left undisturbed suggests that they are unstable. So they can be separated by filtration, a simple method of filtration. You add the suspension through a funnel which has a filter paper, and the chalk, the example we are taking is chalk in water, and the chalk actually gets filtered out. We get the chalk in the filter paper and only the water as a filtrate. Now let's look at what colloid is. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be seen by the naked eye. It's too small to be seen by a naked eye, but it is big enough to scatter light. The scattering of a beam of light is called Tyndall effect. We'll look into that. They do not settle down when left undisturbed, which means they are quite stable and they cannot be separated by simple physical process like filtration. But there are techniques to separate a colloid components, and a technique is centrifugation, which can be used to separate the colloidal particles. Due to the relative smaller size of the particles as compared to a suspension, they might appear to be homogeneous, but actually they are heterogeneous. An example of a colloid is milk. When you see milk, you think it's uniform. When you leave it undisturbed, then nothing settles. So you might get the wrong idea that it is homogeneous, but it's not. It's actually heterogeneous. The solute-like component or the dispersed particles are called the dispersed phase. The medium in which they are dispersed is called the dispersion medium. The solute-like particles are the dispersed phase, and the solvent-like stuff is the dispersion medium. Next, we look into examples of colloids. Colloids are classified according to the state of the dispersing medium and the dispersed phase. That is, if they are in solid, liquid or gaseous state. So there are different types of colloids. If gas is the dispersing medium, then it is called as aerosol. Liquid in gas is called as aerosol. Examples are fog, clouds, mist, etc. And solid in gas is also called as aerosol. Examples are smoke, automobile exhaust, etc. Gas in liquid is called as foam. Shaving cream. Shaving cream. You visualize shaving cream. There are bubbles in liquid stuff. So it's actually gas liquid. And liquid in liquid is called an emulsion. That is what milk is. Milk is an emulsion, as well as face cream. Next, solid in liquid is called sol. Solid in liquid. Solid dispersed in liquid is called sol. An example is milk of magnesia and mud. Next, gas in solid. Gas dispersed in solid is called foam, and examples are foam, rubber, sponge and pumice. An example that we can easily remember is sponge. It has a number of holes in it which gets filled with gases. Now liquid in solid is called gel. Examples are jelly, cheese, butter, etc. You can remember if you just think of the examples, you will get what is dispersed in what. Next, solid in solid. Solid in solid is called solid salt. Solid in solid is called solid salt. Examples are colored gemstone, milky glass, etc. Next, we look into the Tyndall effect that we mentioned earlier. Tyndall effect is a scattering of light by particles of colloid or very fine suspensions. So Tyndall effect is shown by colloids as well as very fine suspensions. This is an example of Tyndall effect. When you pass light through solution, colloid and suspension, the solution cannot scatter light, but a colloid and suspension can, if the suspension is fine. Next. So what we see here is an example of Tyndall effect in everyday life. This is sunlight entering into a dark room through a small hole, in which the path of sunlight is made visible. When a fine beam of light enters a room through a small hole, it shows Tyndall effect. This happens due to scattering of light with the particles of dust and smoke in the air. Next, another example of Tyndall effect is when sunlight passes through the canopy of a dense forest. This is what we get. The reason for this is mist. Mist contains tiny droplets of water, which acts as particles of colloid dispersed in air. As we all know, colloids show Tyndall effect, and this beautiful phenomenon is what we get. So that's it for now. Please like this video and subscribe our channel.